So in today's session, let us see doubts from chapter 1, 2 and 3. So topic by topic, let me ask you. So if you are having doubts, you can clarify. Okay, well, coming to chapter 1, chemical reactions and equations. So this paragraph is related to basics of chemical changes. So which you have studied in your earlier classes like 6th, 7th, 8th, etc. Physical and chemical changes. So changes which are reversible known as physical, which are irreversible known as chemical. So that in information you can get it. So you have to read activity 1.1 where they are talking about burning of magnesium ribbon. So what do you observe? They are asking. So these questions are important. Why? Because in examination, so this information only they'll give. So take magnesium ribbon, burn it, hold it with the help of tongs, burn it. What do you observe? Magnesium ribbon burns with white dazzling flame, and equation related to that one is Mg plus O2 gives rise to MgO. That you have to get information. Any doubts in activity 1.1?
No, sir.
So what information you can get from this is magnesium ribbon, and MgO is magnesium oxide, nothing but metallic oxides. So metallic oxides are basic in nature. So this entire paragraph is important. In this white dazzling flame and changes into white powder. Many times they ask this one. Okay, then activity 1.2, 1.3. 1.2 they are talking about lead nitrate solution, potassium iodide solution. What do you observe? Lead nitrate nothing but salt, potassium iodide nothing but salt. Here activity 1.2 it will give information about precipitate reaction. Precipitate. Then activity 1.3 zinc granules and dilute hydrochloric acid. So zinc granules nothing but metal, and hydrochloric acid is nothing but acid or sulfuric acid. Metal plus acid gives rise to salt plus hydrogen gas. So that information you are going to get from activity 1.2, 1.3. Then here, these are 4 points which are giving information about observations during chemical reaction. So here, following observations will take place during chemical reaction. So this information regarding this, there will be some questions in your examination. Next, any doubts till now here? So you have to read textbook also. Textbook reading is must. Change in state, change in color, evolution of gas, change in temperature. These are 4 observations of chemical reaction. Then topic 1.1 chemical equations. In this, they are talking about word equation. This is word equation. In word equation, you will be representing entire words, and we have reactants as well as products. Reactants means which are participating in reaction. Product means output. After that, here in this information, in this paragraph, you will get information. A word equation shows change in reactants to products through arrow placed between them. Reactants are written on left hand side with the plus sign between them. Similarly, products are written on right hand side with plus between them. The arrow head point towards the product. The arrow shows direction of the reaction. So this small informations you have to get it. Then in 1.1.1, writing chemical equation, converting word equation into symbolic representations. We will be using symbols as well as formulas. Mg plus O2 gives rise to MgO. Then you have to count, compare number of atoms, left hand side, right hand side. Then you have to adjust those numbers. So adjusting those numbers, assigning those numbers making it equal nothing but balanced chemical equations. So you need to balance chemical equation. In this also they will ask you a question. Why equation must be balanced? To satisfy law of conservation of mass. To satisfy law of conservation of mass, equations must be balanced. We need to balance skeletal chemical equation. How? First there will be word equation converted into symbols as well as formulas. Zinc, it is symbol Zn. Sulfuric acid, formula H2SO4 gives rise to zinc sulfate. ZnSO4 is the formula. Hydrogen H2 is the symbol. I think we have studied how to balance chemical equation. Before balancing chemical equation, we need to count number of atoms, LHS and RHS. Regarding this, I have made another video, which I will give you link. So in the link, so after uploading this video, in the description box, I'll give one link. You can observe that video also, how to count number of atoms and how to balance equation. You can get an idea. Okay, they have given some step by steps. If there is any equation, keep boxes and count number of atoms, LHS and RHS. Assign numbers in front of boxes. And here only one thing is, inside the box, what are the numbers are there? Like here, if you can observe, H2O is there. For H2O, you are not supposed to change this 2 because that is according to crisscross method. That is valency. Fe3O4. Here you should not change 3, you should not change 4, etc. Why? Because those numbers are according to valency, crisscross methods. Only you have to assign numbers in front of the box, not inside the box. So that information you will get here. So how to write physical states? So G stands for gas, L stands for liquid, AQ stands for aqueous, S stands for solid. These symbols are important. Then on arrow mark, if you want to show sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reactions are indicated above or below the arrow mark shown in example. So here 340 atmospheric pressure, which is represented on top. Here sunlight, in presence of sunlight, in chlorophyll. So that is written upside or down. So like that you have to go with. Now any doubts till page number 5?
Sir, what is a catalyst, sir?
Catalyst is a substance or element or compound or any other molecule which is used to increase or decrease the rate of reaction. So if reaction wanna become so fast, we will use some chemical that is nothing but catalyst. If reaction must be slow, we will use that is chemical. For example, as I told you, to make rasgulla or palkova or paneer, you need to make milk to be curdled. Naturally, how much time it will take to curdle the milk means it might take days. Today you take the milk, boil it and keep it aside for 2 days or 1.5 days. Then if you boil it, it will be curdled. Instead of 1.5 day waiting, what we will do when it is boiling, we will add some amount of lemon juice. Within 1 minute, instead of 1 day, within 1 minute milk will be curdled. So it has increased rate of reaction. Instead of 1 day, within 1 minute. So that lemon juice is nothing but catalyst, which is used to increase or decrease the rate of reaction. Clear?
Yes, sir.
Then, so here 1.2 topic, types of chemical reactions in this combination. So what this combination reaction will give information. Combination reaction will give information regarding if 2 or more elements or molecules are combined to form only one product. So such type of reactions are known as combination. You can observe CaO plus H2O, calcium oxide, quicklime plus water gives rise to slaked lime. Here, carbon plus oxygen gives rise to carbon dioxide. Hydrogen plus oxygen gives rise to water. Methane plus oxygen gives rise to okay. These are combination reactions. And here there is one another type, that is exothermic. Exothermic reactions means reactions in which heat is released along with the formation of products, called as exothermic chemical reactions. So along with the product, if heat energy is released, exothermic. So here methane plus oxygen gives rise to carbon dioxide and water as well as heat. Do you know respiration is an exothermic process? Why? So there are many questions you can observe in board examination also. They asked why respiration is called exothermic. It is there in page number 7, this paragraph. Maximum students, they won't read this. We get this energy from the food we get during digestion. Food is broken into simpler substances. For example, rice, potatoes, bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combined with oxygen in the cell in our body and provides energy. So that only respiration or digestion is known as exothermic. It will be releasing heat energy. And there is another equation here, most important, which they have asked many times in your examination. C6H12O6, nothing but glucose. If it is reacting with oxygen, it forms carbon dioxide. So that only we are taking glucose. From where are we getting glucose? In this paragraph, you can observe carbohydrates are broken down to form glucose. The food what we are taking will have carbohydrate and it will break down into glucose. Glucose will be present in our body and oxygen we are taking from outside. So that only we are giving out carbon dioxide and we are giving out water in form of sweat and urine, and energy. What energy is released? Heat energy is released. The decomposition of vegetable matter is also an exothermic. Okay, in 1.2.1, you will study about combination as well as exothermic reaction. In 1.2.2, you will study about decomposition. What is decomposition? Decomposition reaction means a single reactant breaks down to give simpler products. This is decomposition reaction. So that is the definition for that. If one reactant, one compound, if it is breaking down into two or more, you see ferrous sulfate. Many times you might have observed this equation in your examination. Ferrous sulfate, if you give heat energy, it breaks down into ferric oxide, sulfur dioxide, sulfur trioxide. So there also there will be gases which will be pungent smell, which will be giving some oxide. So that and all. If you see,
Sir, it is a roasting process, sir.
sorry,
It is a roasting process, sir.
roasting.
FeSO4.
Okay, heating in absence of oxygen, calcination, na?
Sorry, sir.
Yeah.
Same
Okay.
reaction only, no, sir.
Uh-huh.
Same reaction only, no, sir. FeSO4.
Ferrous sulfate, yeah, you can take that one also. Here we are converting into metallic oxide, na? And sulfur
Yes,
dioxide
sir.
is produced. Yes, but
Okay.
it has to be if it is sulfate
Yes.
with roasting. But here, if you are observing heating in absence of oxygen, so it will not. It is neither roasting nor calcination.
Okay.
Yeah, it
Okay,
is
sir.
just
Thank you.
thermal decomposition. Yeah. Okay. Decomposition, again, there are three types: thermal decomposition, electrolytic,
Electrolytic
and
decomposition.
photolytic decomposition. Why? Because for decomposition, energy is required. Now, these all examples which are present in your textbook: ferrous sulfate, calcium carbonate, these all examples of thermal decomposition. This is also example: lead nitrate. is thermal decomposition. In these three, any one you can write in your examination. Here, if you observe activity 1.7, this is passing of electricity through water, but here no equation is given. Here equation is not given, but you have to analyze that equation. In H2O, if you pass electricity, that splits into H2 and O2. So here, for this experiment, equation is, if you take H2O, if you pass electricity, it splits into H2 plus O2. If you want to balance, it becomes 2H2O gives rise to 2H2 plus O2. That you have to learn from this. Activity 1.8, it gives information about photolytic decomposition, where sunlight is used as an external energy. So silver chloride, silver bromide splits into, silver chloride splits into silver and chlorine in presence of sunlight. Silver bromide splits into silver and bromine in presence of sunlight. So that information you have to get from this one. After that, there are in-text questions which we have discussed. Regarding this in-text questions also, if required, I'll give link in description box. Okay, any doubts till now? Combination, decomposition. In decomposition, thermal, photolytic, and electrolytic. Likit Pranati, Zahid Amin, Monica Pritika.
No, sir.
If
No,
you have
sir.
any doubts, you can ask me. I will clarify your doubts. Right. Shall I continue? Okay. Displacement reaction. Displacement reaction means mainly you will take one element plus compound gives rise to new compound plus new element. This element must be metal. This compound must be salt, and this compound will be salt. This element will be metal. But here what we can observe, this metal should be high reactive metal. In this salt, I mean salt is nothing but metallic salt. This metal must be least reactive, so that only we can observe displacement. If this condition is not satisfied, you cannot get displacement reaction. For example, iron plus copper sulfate. This iron is high reactive metal when compared to this copper, so that only you are observing displacement. If you reverse this one, like copper plus iron sulfate, FeSO4. If we take copper plus FeSO4, gives rise to, they'll ask. You see, copper is least reactive, iron is high reactive. So what would be the answer, guys?
FeSO4.
Cu plus
No
FeS,
displacement, sir.
no
No
displacement.
reaction.
Very good. Answer is no reaction. Very good. Like that. So we have three examples: iron plus copper sulfate, zinc plus copper sulfate, lead plus copper chloride gives rise to lead chloride plus copper. Okay. Then double displacement. Double displacements is also known as precipitation reaction. You see, in one paragraph, at last they have given that word, but in examination they will be asking such type of questions only. Double displacement reaction is also known as precipitation reaction. Here you can tell like reaction between salt and salt gives rise to salt plus salt, or you can tell reaction between ionic compound plus ionic compound gives rise to production of new ionic compounds, as well as precipitate is formed. salts which are produced, products which are produced, one will be having least density, another salt will have high density. Salt which is having high density will be settling at the bottom. Salt which is having least density will be floating up. So that only if you can observe, salt with high density, aqueous solution with high density, we are representing as S. S stands for solid and AQ stands for aqueous. So what is meant by aqueous, guys? Any idea?
Mixture of
Share of
water.
sir.
Right. So in water, if you are adding either acid or base or salt, whatever it may be, so it becomes one solution. Acidic solution, basic solution, salt solution. Such type of solutions are known as aqueous solutions. Means in water something should be present. Then ions will be displaced. So two types of displacements we can observe. So that only it is known as double displacement. Then we have a concept called oxidation reduction. Oxidation means,
Addition of oxygen.
very good. We have three definitions. Number one, addition of oxygen. Second definition, removal or subtraction of hydrogen or loss of electrons. Loss of electrons. If you can observe, metals are high oxidizing agent, something they will be telling now. It will be non-metals, if you observe, it will gain electron. Metals, it will be losing electrons. So one example I will tell you. Cu plus O2 gives rise to CuO they gave. Here, copper, okay, here, if you can observe, CuO plus H2 gives rise to Cu plus H2O they said. Now, for hydrogen, H2, oxygen is added. Reactant side we have just hydrogen, product side we have H2O. Means H2 is becoming H2O. Oxygen is added now, so that hydrogen is undergoing, H2 is undergoing oxidation process. Now, what is meant by reduction? For reduction also we have three definitions. Number one, addition of
Hydrogen.
Removal of
Oxygen.
oxygen. While coming to
Gaining
electrons,
of electrons.
very good.
Gaining of electrons.
Very good. Gaining of electrons. Now here if you observe H2, oxygen is added so that it is undergoing oxidation. Now if you observe CuO, reactant side we have CuO, product side we have only Cu, means oxygen is removed. CuO is undergoing reduction process. Now there are some other, now in any equation if you are observing oxidation as well as reduction, it is known as redox reaction. Okay, we have another example now. ZnO plus C gives rise to Zn plus CO. In this, which one is undergoing oxidation, guys? You tell me, which is getting oxygen?
Carbons.
Very good. This carbon is undergoing oxidation process. Reduction process?
Zinc.
No.
Zinc oxide.
Very good. Zinc oxide. ZnO is becoming Zn. So zinc oxide is undergoing reduction, we have to tell. So that is also most important way of representing in examination. MCQs they will give A, B, C, D. In A, zinc is getting reduced. Zinc oxide is getting reduced. You will, if you mark zinc is getting reduced, done. You are done. Wrong. Carbon is getting oxidized. Zinc oxide is getting reduced. That is the answer. Okay, we have oxidation as well as reduction, so that it is known as redox reaction. Now another thing, I'll write one equation. Now we have to tell which one is oxidation, which one is reduction. Ready?
Yes, sir.
Yes. Na plus Cl gives rise to NaCl. You tell me which one is getting oxidized, which one is getting reduced.
Na is getting oxidized.
Nothing,
No,
sir.
sir.
Nothing.
Cl is getting oxidized, sir.
Oh,
Because it is both
There
are
are
gaining electrons, sir.
You should not get confused. Na, sodium is metal, isn't it?
Na
Metal.
will lose electrons.
Metals always it will lose electrons. So here loss of electron nothing but what?
oxidation.
Very good.
Na is oxidation and Cl is reduction.
Chlorine is non-metal. Non-metal always it will gaining of electron reduction. So sodium is getting oxidized. Chlorine is getting reduced. You have to tell. Right. Then 1.3, have you observed the effects of oxidation reaction in everyday life? So 1.3.1, they are giving information
Corrosion
about corrosion. So what is meant by corrosion? If a metal is reacting with maybe oxygen, maybe carbon dioxide gas, maybe hydrogen gas, something gas with moisture. Moisture means amount of water present in atmosphere. It forms a layer on metal.
Yes, sir.
Formation of layer on metal is known as corrosion. Different metals will give different colors. Black coating on silver, green coating on copper, red brown coating on iron. Very good. These all are, you see, here they have given black coating on silver, green coating of copper. And again in third chapter, metals and non-metals, we studied why silver will get black coating, because formation of AgS. And why green coating will get CuCO3, basic copper carbonate .CuOH, right? That and also one chapter is interrelated to another chapter. That is corrosion. How to avoid corrosion, guys?
Galvanization, painting,
Galvanization, painting, tinning,
alloying.
alloying, galvanization, electroplating, many.
Plating.
Yeah. Okay, next, rancidity. What is rancidity? If you take food items which contains especially fat or oil, it is exposed to oxygen, especially when fats and oils are oxidized. Here you can see, when fats and oils are oxidized. What is oxidized? Oxidation is nothing but addition of oxygen only. Oxidize nothing but addition of oxygen. If food items which have fats and oils are exposed to oxygen, it leads to change in its smell or taste. So the changing of smell or taste nothing but rancidity. So how to prevent they becomes rancid and smell? So
Pickling.
you can add antioxidants, keeping food in airtight containers. So you can flush bags of chips with nitrogen using refrigerators. These all are examples of prevention of rancidity. So that is about chapter 1. So I suggest you to read this chapter. Already we discussed this chapter many times. Now also we are discussing each and every line, each and every activity, each and every equation. Every equation you have to spell it from the beginning. I'll tell you what are the equations are there. Let me spell. Magnesium plus oxygen gives rise to magnesium oxide. Magnesium plus oxygen gives rise to magnesium oxide. Zinc plus sulfuric acid gives rise to zinc sulfate. Iron plus water gives rise to iron oxide plus hydrogen gas. Same it is repeating. Carbon dioxide plus hydrogen gives rise to CH3OH. So what is CH3OH? This we will discuss in chapter 4, carbon and its compounds. We will discuss. And carbon dioxide plus water gives rise to glucose plus carbon dioxide. Calcium oxide plus water gives rise to calcium hydroxide. Calcium hydroxide plus carbon dioxide gives rise to calcium carbonate plus water. Carbon plus oxygen gives rise to carbon dioxide. Hydrogen plus oxygen gives rise to water. CH4 methane plus oxygen gives rise to carbon dioxide plus water. Glucose plus carbon dioxide gives rise to glucose plus oxygen gives rise to carbon dioxide plus water plus energy. Ferric sulfate or ferrous sulfate. Ferrous sulfate gives rise to ferric oxide plus sulfur dioxide plus sulfur trioxide. Calcium carbonate gives rise to calcium oxide plus carbon dioxide. Lead nitrate gives rise to lead oxide plus nitrogen dioxide plus oxygen. Silver chloride gives rise to silver plus chlorine. Silver bromide gives rise to silver plus bromine. Iron plus copper sulfate gives rise to iron sulfate plus copper. Zinc plus copper sulfate gives rise to zinc sulfate plus copper. Lead plus copper chloride gives rise to lead chloride plus copper. Sodium sulfate plus barium chloride gives rise to barium sulfate plus sodium chloride. Copper plus oxygen gives rise to copper oxide. Copper oxide plus hydrogen gives rise to copper plus water. Zinc plus carbon gives rise to zinc plus carbon monoxide. Manganese oxide plus hydrochloric acid gives rise to manganese chloride plus water plus chlorine. Like that. Here, sodium plus oxygen gives rise to sodium oxide. Copper oxide plus hydrogen gives rise to copper plus water. In exercise, lead oxide plus carbon gives rise to lead plus carbon dioxide. Iron oxide plus aluminum gives rise to aluminum oxide plus iron. Nitric acid plus calcium hydroxide gives rise to calcium nitrate plus water. Sodium hydroxide, sulfuric acid, sodium sulfate, water, sodium chloride, silver nitrate, sodium chloride, sodium nitrate, barium chloride, sulfuric acid, barium sulfate, hydrochloric acid. Like that. Chemical formulas and chemical equations. You try to spell it, you will get every chemical equation I told. So today your work is read textbook, this chapter 1, entire chapter 1, all concepts from chapter 1, and in text exercise questions also. Spend 30 minutes today, evening or night. Complete chapter 1. Next class, we'll see entire concepts from acids, bases, and salts. Still now, any doubts you have, you can ask. If you don't have doubts, you are free to leave. If you are having doubts, you can stay and ask doubts. You are free to leave if you don't have doubts. If you have doubts, you can stay and ask. So complete reading this textbook, chapter 1, chemical reactions and equations. 30 minutes time you have to spend and complete every line, every activity, every example, every equation. So we'll meet in next class. Thank you. Bye. Have a nice day.